Question 1. Which sequence is a geometric progression? Circle your answer for 1 mark. We're looking for a progression that goes up by a multiple each time. For example, 3, 9, 27, 81. Each time we've got an increase of multiplied by 3. So we're looking for that here. 1 to 2, that would be a multiplier of 2. So that would be 2, 4, 8, which that one is not. However, we've got that one here. Each time we're going up by a factor of 2. 1 times 2 is 2, 2 times 2 is 4, 4 times 4 is 8. Question 2. Which of these is not used to prove that triangles are congruent? Circle your answer for 1 mark. The answer here is angle, angle, angle. And the reason for that is, if we want to know that two triangles are congruent, then that means they need to be exactly the same in size and in angles. For example, we could have one triangle such as this, and one as this. They have the same angles, however they're not congruent because they're clearly not the same size. So our answer, angle, angle, angle. Question 3. Circle the expression that is equivalent to 2a plus 5a multiplied by 4a minus a. We need to know what order to do these additions and multiplications in, and for that we'll use BODMAS, or some may know this as BIDMAS. This tells us that we need to do the multiplication before the addition. So we'll do that first. We have 2a plus 5a multiplied by 4a, that's 20a squared, minus a. Now let's just collect up these two terms. 2a, take away a, that's just a, plus 20a squared. Our answer. Question 4. Circle the equation of a line that is parallel to y equals 5x minus 2 for 1 mark. If we're looking at an equation of a straight line, they're usually in the form y equals mx plus c. In this form, the gradient is the coefficient of x. So we're looking for an equation here that has the same coefficient of x. This one does not, this one does, and none of the others do. So our answer, y equals 5x plus 2, must be parallel to this line here. Question 5. In a sale, the original price of a bag was reduced by 1/5. The sale price of the bag is £29.40. Work out the original price for 3 marks. If it was reduced by 1/5, then that means the current amount is 4/5 of the original price, or 0.8. So to calculate our current amount, we had the original multiplied by 0.8, and that equals £29.40. Finally, to calculate the original price, all we need to do is divide by this 0.8, so that's £29.40 over 0.8, which is £36.75. Question 6. We need to complete this Venn diagram given the information above. This is our total set of numbers from 1 to 12, and we need to sort them into square numbers and even numbers for 3 marks. So 1, that's a square number. 2, that's even and not square. 3, that goes outside because it's odd. 4, that's a square and even, that's going to go in the middle. 5, that's odd. 6, that's even. 7, that's odd. 8 is even. 9 is odd and a square, so it's going to go here. 10 is even. 11 is odd and not a square. And 12 is even. So that's our completed Venn diagram. One of the numbers is chosen at random. Write down the probability of S intersect E, that's it being a square number, intersection with it being an even number. If we look at the Venn diagram, that region is here, where the square numbers and even numbers intersect, so that's 4. There's only one of them divided by a total of 12 numbers. Our probability is 1/12. Question 7. A coin is rolled onto a grid of squares. It lands randomly on the grid. To win, the coin must land completely within one of the squares. Mira and John each roll the coin a number of times and record their results as below. Work out 2 different estimates for the probability of winning. We could work out Mira's estimate, that's 6 wins, over a total of 50 rolls. 6 times 6 plus 44. So 6 over 50, that's equivalent to 3 over 25. That's one of our probabilities. Next, we can find John's probability. His probability is 28 over 100 from 72 plus 28, which is equivalent to 14 over 50, 7 over 25. Which of our estimates is the better estimate for the probability of winning? Give a reason for your answer. Our answer is this one here, 7 over 25. And the reason being is John had 100 trials of flipping the coin, and Mira only had 50. And because John used a larger data set, his estimate is going to be more accurate. So it's 7 over 25 because a larger sample was used. Question 8. Here is the graph of 4x minus 3y equals 12 for values of x from 0 to 4. By drawing a second graph on the grid, work out an approximate solution to the two simultaneous equations. So, we already have 4x minus 3 equals 12 on the graph, so we need to plot this graph here. 3x plus 2y equals 6. In order to do that, we need at least 2 points. We know it's a straight line because it's in the form y equals mx plus c if we were to rearrange. So, let's find the point for x equals 0. If x is 0, we only have 2y equals 6, so y must equal 3. And similarly for y. If y is 0, we have 3x equals 6, so 6 divided by 3, x equals 2. Now we need to plot those 2 points, so we'll go to x is 2, y is 0, that's here, and x is 0, y is 3, that's up here. Now we just need to join these with a straight line. Now that we've plotted 3x plus 2y equals 6, we simply need to read this point here to get our solution. So the x value, if we read up, is 2.5. So x is 2.5. And the y value looks to be around minus 0.7. Question 9. Write 252 as the product of its prime factors for 2 marks. I'm going to use that using a factor tree. So 252 we know is divisible by 4 and 63 using a calculator, and we can divide 4 into 2 and 2. These are both prime, so we're going to circle them. We don't need to look any further for further factors of these numbers. 63 isn't prime, it can be split up into 7, which is prime, and 9. And 9 is not prime, it has 2 factors, 3 and 3. So if we want to write these as a product of its prime factors, we have 2 squared times 7 times 3 squared. We're writing 2 squared for 2 times 2, so we have 2 factors of 2. 9b, work out the value of the highest common factor of 672 and 252. We're given the prime factorization of 672 here, so we just need to look at what's common in both of these. We've got 2 to the power 5 and 2 to the power 2. The highest power of 2 there is 2 squared. We've got 7 and 7. The highest power of there is 7 to the power 1. And we've got 3 and 3 squared. The highest power there of 3 is just 3. So we've got 4 times 7 times 3, which is 84, the highest common factor of 672 and 250. Question 10. At a school, the number of boys to the number of girls is the ratio 9 to 7. There are 116 more boys than girls. Work out the total number of students at the school. First, we need to start with the ratio. Boys to girls was 9 to 7. The difference between these is 2. We want to manipulate this ratio and multiply it by some number so that the difference is 116. To get there, we see what we need to multiply 2 by to get to 116, that's 58. Next, let's multiply both parts of these ratio by 58 to find out the new ratio of boys to girls, the actual number of boys to girls in the school. 9 times 58 is 522, and 7 times 58 is 406. They're the actual numbers of boys and girls in the school now. So, to find the total, we just need to add these together. 522 plus 406 is 928 students in the school. Question 11. Circle the equation with roots 4 and minus 8. A root is the solution of an equation. If you substitute a root into an equation, it should equal 0. So we need to find which one of these we can substitute both 4 and minus 8 into to make it equal 0. To do that, we could substitute each value into every single equation, or we could notice that for this equation, if we substitute 4 in, we get 4 minus 4, that's 0. 0 times this should be 0. And if we substitute minus 8 in, we'll get minus 8 plus 8. So this bracket will be 0. We'll have whatever this bracket is times 0, which equals 0. For both cases, this equals 0. So this is the equation with the roots 4 and minus 8. Question 12. R equals x squared over y, with the values of x and y given. Work out the value of r. Give your answer in standard form to an appropriate degree of accuracy for 3 marks. First, let's calculate what x squared is. So x squared is simply 3.6 times 10 to the 5 all squared. In order to do that, we can put that in straight into the calculator. So that's 1.296 times 10 to the power 11. Next, we need x squared over y. Let's take this 1.296 times 10 to the 11 and divide it by the value of y. That's 7.5 times 10 to the 4, which gives us an answer of 1.728 times 10 to the 6. Finally, we need to give this to an appropriate degree of accuracy. If we look here, we see y equals 7.5 times 10 to the 4. That's to 2 significant figures. We should do the same thing here. So that would be 1.7. We need to round down times 10 to the 6, 2 significant figures. Question 13. 2 spheres have radii in the ratio of 5 to 3. Circle the ratio of their volumes. If the ratio of the radius is 5 to 3, that's a length. So the ratio of the volumes must be that cubed. So 5 cubed to 3 cubed, which is 125, 27. 14a. A pattern is made from 2 similar trapeziums. Show that the shaded area is 294 centimeters squared. If they're similar, that means there's a scale factor between them. A number that if we multiply one length, we'll get the corresponding length on the other shape. So this length corresponds to this length here. It's been rotated. So we need to divide 10 divided by 4, which is 2.5. That's our scale factor. So the large shape is 2.5 times bigger than the small shape. Next, we need to calculate some other. Next, we need to calculate the height of the small one. We have the height of the larger shape, but we don't have the height of the small shape yet. So, in order to do that, we can do 25, the height of the large shape, divided by the scale factor, that's 2.5, equals 10 centimeters. So this length here is 10 centimeters. The other length we need is this one here to calculate the area of the small trapezium, and that's the corresponding length to that is this length here. So we need to take 18, divide it by 2.5 because it's 2.5 times larger, which is 7.2 centimeters. Next, we need to find the area of these two shapes. So let's find the area of the large trapezium. So if we call the large trapezium A and the small one B. So area of A, find the area of the trapezium, we need to average the two parallel sides. That's a half of 18 plus 10, and then multiply by the height. That's 25. Gives us an area of that shape of 350 centimeters squared. For the small shape, we'll do the same thing. So the average of the two parallel sides, that's 4 plus 7.2, multiplied by the height of 10, which gives us an area of the small shape of 56 centimeters. Finally, to find the area of the shaded area, we just need to take the small one away from the large shape since the small one is completely inside it. So 350 minus 56 equals 294 centimeters squared. 14b. The pattern has one line of symmetry. Work out the size of angle x. So here's angle x, and we know that these two lines are parallel since we have a trapezium. So if we are to extend this to here, that has to be angle x as well, since these are alternate angles. We have a right angle there. If we knew this side length here, we could use trigonometry to calculate the value of angle x. We know that it has one line of symmetry, which is likely down the middle here, we can see. So there's going to be a similar side on this side of the shape. Find out the side length, we can do 18 take away 10, which gives us the total of these two lengths. That's 8 centimeters in total, and since it's symmetrical, they both have to be the same size. So that's 8 divided by 2 will be 4 centimeters. Next, let's label our triangle for trigonometry. If this is the angle we want to calculate, we have the opposite side and we have the adjacent side. This is the hypotenuse here. That means we'll want to use the ratio for tan, which is opposite over adjacent. Now let's put some values in. So tan x equals 25 over 4. So that means to calculate x, we'll have to do inverse tan of 25 over 4, which gives us the value 81 degrees for two significant figures. Question 15. Anne picks a 4-digit number. The first digit is not 0. The 4-digit number is also a multiple of 5. How many different 4-digit numbers could she pick? For 3 marks. So for example, the number 1005 is one of these potential numbers because it's a multiple of 5, it ends in 5, and the first digit isn't 0. The best way to consider this is to consider what different combinations of digits there could be. For example, the last digit has to be either a 0 or a 5, so I'm going to write down that there are 2 possible digits for that last digit in the number. Similarly, for the first digit, we know that it's not 0, so all the other numbers from 1 to 9 can be included, so that's 9 possible digits. And these 2 digits in the middle could be anything from 0 to 9, so that's 10 possible digits for each. Finally, to find out how many different numbers she could pick, we need to multiply these numbers together, find the different number of combinations that could be possible. So 9 times 10 times 10 times 2, 1,800 different numbers. Question 16. C is a positive integer. Prove that the expression is an even number for 3 marks. So we're going to start with this. We need to try and find a way to simplify this. There's nothing we can divide through immediately, aside from potentially 3, but it'll be easier to do that later on. So let's take the top of the fraction and the bottom of the fraction, and in turn we're going to try and factorize them to see if there's any simplifications we can make. For 6c cubed plus 30c, we see that we can take out a factor of 6, because 6 goes into 6 and into 30, and one factor of c, because c cubed and c both include c. So let's do that for the top of the fraction. So we have 6c on the outside, and on the inside we need to know what 6c multiplies by to get 6c cubed, so that's 6c squared, and what 6c multiplies by to get 30c, which is 5. Similarly for the bottom of the fraction, we notice that 3 and 15 both divide by 3, and there are no common factors of c in both of these. So we're simply going to have 3 on the outside, and c squared plus 5 on the inside. Next thing that we can do, since we've got the same thing on the top and the bottom, we can cancel out both these c squared plus 5s, and that leaves us with 6c over 3. If we do 6 divided by 3, that's 2, so that leaves us with 2c. So 2c is an even number, because any number multiplied by 2 has to be even. So we start with 7, we'll have 14. Start with 8, it's already even, but we'll have 16. So 2c is even for all numbers, and that's our 3 marks. Question 17. Given the above information, work out the average speed of the Earth in miles per hour for 4 marks. To calculate speed, we need to know the distance and the time taken. The distance in this case is the distance around the Sun, which we're told it as it travels in a circle, and the distance there would be the circumference, which we know is pi times the diameter. The diameter would be 93 million miles times 2, because this is the distance from the Earth to the Sun. So we need 93 times 2 times pi, which would equal 186 million Next, we need to know the time taken. We're told it takes 365 days, which is 365 lots of 24 hours, 8,760 hours. Finally, we can use the formula speed is distance over time, which is 180 million I over 8,640 hours, which gives us an average speed of 66,700 miles per hour. That's the three significant figures. 17b. It actually takes 365.5 days for the Earth to travel once around the Sun. How does this affect your answer to part A for 1 mark? So, if the time taken is increased very slightly, that means the bottom of the fraction has increased slightly. If we increase the bottom of a fraction, this number is going to be larger, so we're going to be dividing by a larger number, so the speed will decrease. And that's our answer. Average speed is lower. Question 18. In the formula t equals n minus 6 all squared plus 1, n is a positive integer. Kim says that the value of t is always greater than 1 because n minus 6 all squared is always greater than 0. We have to comment on her statement for 1 mark. So, let's see what we can substitute into here and see what changes the value of it. If we select n is 6, then t will be 6 minus 6 all squared plus 1. 6 minus 6 is 0, and 0 squared is 0, but 0 plus 1 equals 0. Kim claimed that the value of t is always greater than 1, however in this case the value of t is 1. So her statement is false. And that's all we need to do for that mark. 18b. What is the only value of t that is a square number for 1 mark? So for higher values of t than this, we're going to have a square number, n minus 6, so whatever that is, squared is going to be a square number, plus 1. So there's no cases in which a square number plus 1 could equal another square number. So the only value that is a square number is this 1 here, because 1 equals 1 squared. Question 19. f of x equals 3x. Circle the expression for the inverse of f of x. To find the inverse of f of x, we'll first write y equals 3x. Now we need to rearrange so that x is the subject. So in this case, we'll have y over 3 equals x. Our final step is to swap y and x in the equation. So we'll have y equals x over 3. Or we would write that as inverse of f of x is x over 3. Question 20. Y is directly proportional to the square root of x. Work out the value of a for 4 marks. The first thing we can write is y is directly proportional to the square root of x, and if we introduce a constant, we would say y is k times the square root of x. In this case, we have a value of x and a value of y, so we can use that to calculate the value of k. Let's substitute in these two values. So 2 equals k times the square root of 36. 2 equals k times 6. So k is 2 divided by 6, or 1/3. So now we have our equation y equals 1/3 times the root of x. To find out a, we need to substitute in y and rearrange to find out the value of x. So let's substitute in 5 for y equals 1/3, and I'm going to write a because that's what we're trying to calculate. To try and separate this on its own, let's multiply by 3 to get rid of this third. That will be 15 equals the square root of a. And we'll square both sides to remove the square root. So a equals 15 squared, which equals 225. Question 21. A company makes boxes of cereal. A box usually contains 450 grams of cereal. We have 2 options for the special offer. Option A, where 20% more cereal is contained, but the price is the same. And option B, where we have the normal amount of cereal, we get 15% off the price. Which option is better value for the customer? We must show our working. 3 marks. So we need to consider both of these in separate instances. The way we're going to try and do it is to figure out what the value of 1 gram of cereal is for each option, and then we can compare the two and see which is the better value. The cheapest gram is the one that we want to go for. First of all, in order to do that, we're going to say X is the cost of a box of cereal. Because we don't actually get given that in the question, so we've got to assume it. So if we want to figure out how much cereal there is in a box of option A, we start with 450 grams of cereal, and we get 20% more cereal. That's a multiplier of 1.20. So 450 grams times 1.2 is 540 grams of cereal in a box of cereal A. The price stays the same, so the price per gram is X, the cost, divided by 540 grams, which will give us 1 gram. And as a decimal, we can write that as 0.00185x. So if we knew the price, say it was £5, we could do 5 multiplied by this answer, and it would give us the actual cost per gram. Let's do the same for B. We get the normal amount of cereal, but we get 15% off the price. A 15% reduction is the same as a multiplier of 0.85, since that's equivalent to 85%. So we would say that the new cost is 0.85 times X, the old cost. If we want to know the price per gram, we take the cost, as we did before, and divide it by the number of grams. In this case, there's 450 grams in the box because it's the usual amount of cereal. If we make that division, we get 0.00188x. So we can now compare these two. We see that this one is the smaller number. We've got x in both of them, but the coefficient here, the number in front of it, is lower. So in this case, we want to select option A as better value because the cost per gram is lower. Question 22. The histogram shows the ages in years of members of a chess club. There are 22 members with ages in the range 40 to 65. That's this one here. Work out the number of members with ages in the range 25 to 40. So we want to know this one. So on a frequency density diagram, the area represents the number of people. So we need to first calculate the area of this to see what the scale is on this left-hand side. So the area here is 25 multiplied by 11 squares up, which is 275 squares in total. And then if we divide the number of people that this represents by the number of squares, we can find out how many people one single square is worth. If we know what one single square is worth, and we knew how many squares were in this, we could multiply this by the number of people per square to get the number of people. So 0.08 people per square. So next, let's calculate the area of this. So we've got 25 to 40, that's 15. And the height of this looks to be 30. That's 450 squares. Now all we need to do is multiply the number of squares by the number of people per square, and we'll know the number of people that this represents. So 450 multiplied by 0.08 equals 36. Question 23. A bowl is a hemisphere with radius 6 centimeters. Water fills 2/5 of the volume of the bowl. The water is poured into a hollow cone. The depth of the water in the cone is 12 centimeters. Work out the radius of the surface of the water in the cone. So we need to figure out this length here, and we'll call that x. In order to work this out, we need to know the volume of water that was poured into this cone in the first place. So we need to calculate the volume of water in the hemisphere. We know that 2/5 of the volume is filled with that. So if we knew the volume, we could multiply by 2/5 to get the actual amount of water. Let's calculate the volume of the hemisphere. We know the volume of a sphere is 4/3 pi r cubed, and a hemisphere is half of that. So the volume of the hemisphere will be 2/3 pi r cubed, because 2/3 is half of 4/3. We know the radius is 6, so we can do 2/3 times pi times 6 cubed, which equals 144 pi. We leave this in terms of pi for now since it'll make our calculations more accurate later on. The volume of the hemisphere is 144 pi, but we want the volume of the water, which we know from earlier is 2/5 of the volume of the hemisphere. So 2/5 times 144 pi, which equals 57.6 pi. Now let's calculate the volume of the cone. We're given that the volume of the cone is 1/3 times pi times the radius, which in this case is x cubed, times h, 12. Sorry, that's x squared. So that should give us 4 pi x squared. Now we can equate these two. 4 pi x squared equals 57.6 pi. And the reason we can equate those is this volume of water is the same as this volume of water. We can cancel the 2 pi's and divide by 4 to get x squared equals 57.6 over 4. Our last step is to calculate the square root then of 57.6 over 4, which equals 3.79, be significant, 3.79. Question 24. A big wheel is modelled as a circle with centre O and radius 15 meters. The wheel turns in an anti-clockwise direction. The lowest point on the wheel is always 2 meters above horizontal ground. C is a point on the wheel h meters above horizontal ground. The angle COB x degrees, and we need to show that h equals 17.5. 17 minus 15 cos x. So we're looking for this length. So in order to calculate that, we'll first need to know this length here and the total length. The total length is quite straightforward. We know the radius is 15, so the distance from O to the edge of the circle is also 15. We just need to add on that 2. That means the distance from O to B is 17. If we want to calculate this length here, we're going to have to use trigonometry. We want this length, and we have this length here, that's the hypotenuse, and this related to x is the adjacent. So we need to think of which trig ratio includes that, and that's cosine. So we can write cos x equals adjacent over hypotenuse. In this case, we can call adjacent simply a, and the hypotenuse is 15. So the adjacent side is simply 15 cos x. Next, we need to figure out what h is. If we know that 17 is the full length and this side is 15 cos x, we can take h, 17, take away the smaller length here, 15 cos x. That's our 2 marks. Question 24b. D is a point on the wheel and the angle DOB is 120 degrees. Work out the height of D above horizontal ground. In the first part of the question, we said that this height was h, which we figured out an expression for, which is 17 minus 15 cos x. To find out the height of h, we need to substitute x, the angle, 120 degrees. So we'll say h is 17 minus 15 cos of 120, which is 17 minus 15 minus a half, which equals 24.5 meters. Question 24c. Here is a sketch of the graph h equals 17 minus 15 cos x for one complete turn of the wheel. P is the highest point on the graph. Work out the coordinates of P. So the wheel starts turning here from the bottom, and it turns anti-clockwise all around the circle until it returns to 2. And we can see that from the graph. It starts at 2, and it goes up to the highest point, and then returns to 2. We know the highest point is up here, which if we're thinking in terms of our angle x has to equal 180 degrees at the highest point of the circle. So all we need to do is substitute this into our equation for h to work out the coordinates. We know that x is 180, we can put that in immediately. And we have h equals 17 minus 15 cos 180. Cos of 180 is minus 1, so we can write h equals 17 minus 15 times minus 1, which is 17. Take away negative 15, which would be plus 15, so h is 32. Question 25. 2x squared minus 6x plus 5 can be written in the form a x minus b all squared plus c, where a, b, and c are positive numbers. Work out the values of a, b, and c. This format tells us that we need to complete the square on this expression. In order to do that, we'll start off by writing it in a factorized form as such. So we're taking a factor of 2 out of each of the terms. So 2x squared becomes x squared here, minus 3x, and this will be written as 5 over 2. The next step is to look at this expression inside, and we'll complete the square. I'm going to leave the 2 there for now, we'll come back to it later. Our method for completing the square is to divide this number by 2, that's 3 over 2, and put it inside a square bracket. We now need to adjust this because this isn't the same as this expression. Minus 3 over 2 squared is 9 over 4. We'll take that away, and that will leave us with x squared minus 3x. This is equivalent to x squared minus 3x. So to make sure that this is equivalent to the whole thing, we need to add on 5 over 2. Now let's multiply through by 2. We get 2 x minus 3 over 2 all squared. This is already looking like this a x minus b all squared. Minus 9 over 2 plus 5. The last thing we need to do is combine these two. So we'll have 2 x minus 3 over 2 all squared plus a half. So our values here of a is 2, b is 3 over 2 because we've still got the minus sign in both of them, and c is a half. Question 25b. Using your answer to part A or otherwise, solve the equation 2x squared minus 6x plus 5 equals 8.5. So in order to do that, we're going to have to set this equal to 8.5. If we want to solve it, we'll first rearrange by taking away 8.5, so we've got 0 on this side. So that would be 2 x minus 3 over 2 all squared, and a half, take away 8.5, is simply away 8. Let's start rearranging. We want to try and calculate what x is, so we'll need to add 8 and then divide by 2. So x minus 3 over 2 all squared. We'll have 8 on this side and then we'll divide it by 2, so that will be left with 4. X minus 3 over 2 equals plus or minus 2. So the square root of 4 is plus or minus 2. And our final step is to add on this, so x is 3 over 2 plus or minus 2, which gives us two different solutions. One in the case that we're adding on 2, which would give us 7 over 2. Or in the case that we're taking away 2, which would give us 3 over 2 take away 2, which is minus a half. There are two solutions, x is 7 over 2 or minus a half. Question 26. Two boxes are made with card. The boxes are similar cuboids. The smaller box has a height of 32 centimeters. It takes 44% more card to make the larger box. Work out the height h of the larger box. Because they're similar, that means we have a scale factor between these two cuboids. We know that the scale factor of the volume is 1.44. This is a 40% increase. That would be 1.44 as a decimal. Now, if we know that this is the scale factor of the volume, to work out the scale factor of the height, we simply need to take the square root. The square root of 1.44 is 1.2. So that's the scale factor of volume, and this is the scale factor of height. So now we've got the height of the smaller cuboid, we want the height of the large one, so we can multiply by this scale factor. That's 32 multiplied by 1.2 is 38.4 centimeters.